Okay, so today we're talking about two properties for algebra that help you solve multi-step problems: the distributive property and combining like terms. We've learned a lot about algebra in just a few classes. You know how to solve a one-step algebra equation like this so far. So hopefully that's coming along now and you feel comfortable. You see subtraction here, so you do the opposite, and then you're going to do addition. You're adding 7 to each side. That allows these to cancel out. And we have x equals 19. And we started doing two-step algebra equations last week like this as well. X divided by 4 plus 5 equals 6. Do I want to start unraveling my x over 4 first or my plus 5 first?
Plus 5.
That's right. You want to get rid of the plus 5 here by doing the opposite, which is subtracting 5 from each side. These will cancel out, but I still have to keep my x over 4 on the left side. Equals 6 minus 5 equals 1. And this is why it's a two-step problem, because I still have to get rid of this 4 in the denominator under the x. How can I get rid of a division problem here like this? Right, you can undo this division problem by multiplying each side by 4. And with fractions, a numerator cancels with a denominator. And then I'm left with x on the left. 1 times 4 is 4. So that you should be pretty comfortable with already. But hold on to your hat, because today we will learn how to solve algebra problems with more than 2 steps. Learning about the distributive property and combining like terms will help us solve some of the harder problems. Let's talk first about the distributive property. It's a long word. When you distribute something, though, like say you were a UPS driver, if you're distributing packages, you're giving something. And that's the same thing in math. The distributive property helps make numbers easier to work with, and it's a good way to get rid of pesky parentheses. So to distribute something means to give something out to each member of a group. Let's look at a math example that involves food. All right, some of you might have this happen to you a lot. You're hungry at lunch and you want to go out. Suppose that you and 2 friends go to a food truck for lunch. You each want to buy a combo meal that consists of 2 tacos, and 1 soft drink. It says 1 combo meal. Each meal has 2 tacos and 1 soft drink. And here's how you can show that mathematically if you just put a 3 in front of it, because how many people are going out for lunch? You and 2 friends. That's 3 people are going out for lunch. 3 people are getting this entire combo meal for each of them. So obviously each person is going to get, or the total then will be 6 tacos and 3 drinks. So how do you do that mathematically? You carry your 3 through the parentheses here with multiplication. 3 times 2 tacos becomes 6 tacos, plus 3 times the d becomes 3d. So in total, you and your friends would receive 6 tacos and 3 soft drinks. The distributive property allows us to multiply the 3 throughout the parentheses, and then we can just get rid of the parentheses entirely. So let's simplify some of these algebra expressions using the distributive property. Let's do the first one here together. So this 5 is going to get multiplied, and you can tell it's multiplication because it's implied. It's sitting right next to this group here. The 5 gets multiplied with the x, and then the 5 gets multiplied with the 2. So the 5 is being multiplied by each member of the group inside the parentheses. What's 5 times x? 5x. And then you keep your addition sign here. What's 5 times 2?
10.
Right. And a lot of people want to say 5 plus 2 is 7. But you can't do that because we're working here with multiplication. The distributive property is about multiplying through, right here. So that's simplified. Go ahead and try the next one. Multiply the 4 through the 3x, and then multiply it through with the 1. So 4 times 3x would be 12x. And then you keep your symbol, your operation symbol that you have there. Subtract 4 times the 1 would be 4. Did anybody get 12x minus 4? Yes, good. All right, how about 3x being multiplied through like this? We haven't done a whole lot with these yet. Let's do this one together. This is tough. All right, so I have a group with 2 terms in it. First, I've got to do 3x times, because there's my times, it's implied, times 2x. 3 times 2 is 6. What is x times x? Squared, right, x squared. Keep your same symbol. Now 3x times 5 is going to be 15x. Well, that's a tough one to learn. You get a couple of these types of problems in your book. All right, last one. This one has a negative, so don't forget to carry the negative through with it. If the negative is attached to this number here, it must get multiplied through each term. All right, so a negative 8 times a 2x, keep your negative, becomes a negative 16x plus negative 8 times 3, that's a negative 24. Yeah, you could rewrite it if you want to like this, negative 16x minus 24. Either of those is fine. So then on the next page, rather than just simplifying, you're actually solving. This is algebra now. Solve these algebra equations for x using the distributive property. There's a couple of different ways that you could do this. Some of you might want to go ahead and divide through each side by 2. We have been doing them that way. But go ahead and try and see if you can use the distributive property here. Work it through. Remember, in math, there's more than one way to do a problem. And go ahead and work on all 4 of those, and then we'll do them together. let's go over these problems now. So the 2 is being multiplied throughout this group here. 2 times x is 2x. Keep your sign. Minus 2 times 3 was 6 equals 10. Now you're back to a 2-step algebra problem. Add 6 to each side. These cancel. 2x equals 16. Now divide through. Undo multiplication with division. Divide by 2 on each side. X equals 8. Did anybody get 8? Good. Excellent. That was tough. 3-step problems here now. Okay, now work this 10 through. Hopefully you did it like this. 10 times 5x would be 50x. Keep the sign. Plus 10 times 2 is 20. Equals 120. That was one step. Your next step, your second step, is going to be subtracting 20 from each side. That lets me cancel out these. You still have 50x on the left equals 120 minus 20 equals 100. Now your third step then is to undo this multiplication problem. How do I undo this problem here? Dividing, someone said. That's right. Divide each side by 50. Now you have x equals 2. Did anybody get 2? Good. All right. Multiply this one through. 7 times 2x would be 14x. Keep your sign. 7 times 5 is 35. And the right side says equals 21. That was step 1. Step 2 then is to undo this subtraction with addition. Add 35 to each side. These cancel. You have 14x on the left, and then you have 21 plus 35. Is that 56? So then your third step is to undo this multiplication with the inverse, which is division. It's getting complicated, isn't it? X equals 56 divided by 14. What is that? 4? All right, last one of these. Work your 6 through the group. 6 times x is 6x. Keep your sign. Plus 6 times 4 is 24 equals 33. That was step 1. Step 2 then is to get rid of this addition problem by subtracting 24 on each side. Cancel these. You're left with 6x equals 33 minus 24. Is that 9? Okay. Now you have multiplication. Divide through the 6 on each side. That will allow you to cancel here. Now you have x equals 9 over 6. We could leave it like that, or we could reduce. Let's go ahead and reduce. 3 goes into both of these, right? Let's divide the top by 3 and the bottom by 3. 9 divided by 3 is 3. 6 divided by 3 is 2. Then you can still reduce further if you don't want an improper fraction. You could turn this into a mixed number. 2 goes into 3 one time completely, and there's 1 left over. That would be 1.5, in case you can't see that there. So that is the distributive property. It's multiplying a number through parentheses, and making sure that you get each term in the parentheses. Now sometimes you'll have a problem that might have, for instance, 6x plus 4 plus 1. You can multiply this 6 through each term, and then you'd actually have like this: 6 times x, 6 times 4, and 6 times 1. It doesn't just have to be 2 terms. You can go as many terms as they give you. But the key is that this number has to get multiplied through every term that you see in the group. So now we're talking about combining like terms. That's our second concept for the day. Let's look at a silly example to start off. Do you see any pictures in this number sentence that you can combine? Yeah, the houses, right. So you have 4 hearts plus 5 houses plus 2 houses. Let's rewrite that. 4 hearts plus how many houses?
7.
That's right, and you didn't even learn this yet, right? It's just kind of intuitive. Plus 7 houses. That's good enough. There we go. I'll just put a little chimney there. There. So hopefully you recognize that you could combine the houses somehow. Did you add 5 plus 2 and end up with 7 houses? If so, your brain is getting the hang of algebra. Yay! Now create a number sentence using any pictures you like. Like I used the heart and the house. Make up anything that you want. So be sure to include a picture that appears more than once, so you have to add or subtract them. I want you to make a sentence like I did. And I'll make another one down here too. Okay, let's see. So use any symbols that you want. Have at least 3 terms. And when you're done creating it, be sure that you can simplify it. For instance, here I have stars that are the same. So I need to make sure that I group those together. 2 stars minus 1 star. Well, if I have 2 stars, I take away 1 star, I'm left with 1 star. And I still have 3 flowers. Did you understand how we did that? All right, now on to the next page here. So it's fun using pictures, but we have to know how to work with variables like x's and y's. So let's rewrite our original number sentence using x's and y's instead. Every time you see a heart, we're going to replace it with an x. And every time you see a house, we'll replace it with a y because they're different. I'm not going to use an x for each of them. A heart is different from a house, so I'll give it a different letter, different variable. Let's pull up the old picture here. The old picture looked like this. It said 4 hearts plus 5 houses plus 2 houses. So I'm going to put an x in place of my heart. Now I have 4x plus 5, put a y in place of the house, plus 2, again put a y in place of the house. I've changed this picture sentence into algebra. 4x plus 5y plus 2y. And just as I did with the houses, I can combine my y's. 5y's plus 2y's would be 7y's. So notice that you did not have to solve the problem in this case. You just simplified the problem by collecting what's called like terms. Like terms match. So try a harder one that has a negative number. Collect the like terms together. And sometimes when I'm doing them, I will use a different color or I'll highlight. So I'm going to go through and pick all of the x's. That's an x term. This is an x term, and notice the negative with it. There's another x term, and that's it. So I can combine these. I've got 7 of them here, 7 x's here, minus 2 of them here, that's now I'm up to 5, plus 3 of them here, I have 8 x's. I combined these 3 terms into one because they matched. Do you see anything else in that problem that you can combine? Y's, right. Let's look at the y's now in a different color. I've got 9 of them here, and I have 2 of them here. If I add that together, what do I get? I think I heard 11. 9 plus 2 would be 11 y's. Am I done? Don't forget your 2. There you go. Now it's simplified. You can even combine terms that look like this, and we haven't done a whole lot with x's that are squared or cubed, but we're going to be starting that now. As long as the variables are the same. By variable, I mean the x and whatever exponent is attached to it. They have to match. So I have 4x squareds here, and I'm subtracting 2 of them here. So I'm left with 2x squareds. In this case, I have xy together, and I have another xy over here. So I've got 9 of this group here, and I'm subtracting 5 of this group here. So I have 4 of them. The key is to make sure that they match. To combine like terms, the term must have the same variable and exponent. So for example, you can combine 3x squared plus 2x squared and get 5x squared. But you can't combine 3x plus 2x squared. Take a look there, because you see this has an exponent here. I don't have one here. So those don't match. Now let's look at a harder example. Figure out if you can combine any of these terms. Again, if you have a highlighter or different colors, that's always very helpful when you're doing these problems. I like to start with the highest exponent. Which one is the highest exponent here? 4, that's right. 4x, because this is a cubed, it's a 3. I would just put that one first, although it's not mandatory. So I got rid of that one. Now, when I'm working with my x squareds, I see more than one. So let's make sure we get them. I see 1 here, and I see negative here. There's not a number or a coefficient in front of this one, though. So what is it? A 1. That's right. You assume that's a 1 if there's nothing in front of it. So 3 of this group here minus 1 of this group here is 2. 2 of that group. So we did that one, we did that one. So what's left? Just some loose numbers? Negative 7 plus 2 would be negative 5. Does anybody get that? Very good. All right, last page here. Look at the following solutions and decide if the terms have been combined correctly. So you're going to want to make sure that they are like terms, first of all. X and X are. I don't see any exponents, so that's fine. I have 5 of them here and 5 of them here, which is 10x. Is that right or wrong? Right. It's right. I'm just going to put a check, but you could put the word right or whatever you want to do. So go ahead and work your way through the rest of this table here. You either put a check and an X, or you can put right or wrong. You have to look carefully at the exponents when you're combining like terms. here, an x here, a y here, a y here, and a squared. The squares aren't applying to the right one, so they have to match exactly. So I can have this. Are those like terms? X squared y, 3x squared y. Are these like terms? Oh, yeah. They are, right. It doesn't matter what this coefficient is here. The big number doesn't matter. But these have to match that goes exactly. So this was not a like term, no. And this is a like term, yes. All right, back to our table. So for this one, we have 7x minus 1x plus 2x is 8x. Right or wrong? Yep, that is right. And in this case, we have a 4x here being added to a 2y. Can you do this?
Wrong.
Right, that is wrong. Nope, you cannot combine these terms because an x is totally different from a y. Yep, they're totally different things. Let's look at this one. This is getting more complicated. xy squared. Let's look at this one here. xy squared, xy squared. Oh, so these groups all match. I have 1 of them here, 2 of them here, and 6 of them here. Does that give you 9xy squared? It does. That's right. All right, the next one. 3y plus 3xy minus 2x. Can you combine them like this? 4xy.
No.
That is wrong. You cannot do that. In this one, you have 3x squared minus x squared plus a y. Well, this would have given me 2x squared, right? Plus a y. Can I tack the y on at the end like that? No, because that means multiplication when you squish it up like that. This was addition. That is wrong. All right, last one here. 10x squared plus 5x minus 3x squared minus 7x. Let's collect the x squareds first. I've got 10 of them here and minus 3 of them here. So 10 minus 3 is 7. So far, that is true. Can you do 5x minus 7x and get negative 2x? 5 minus 7 would be negative 2.
Yeah.
Can, yep, so this is true. This is right. So these notes were challenging today, but we're almost done. I'd like for you to solve these algebra problems here and be sure to combine like terms. Notice that up above, I did not give you an equals sign here, so you weren't being asked to solve anything, just simplify. Down here, I'm giving you the equal sign, which means you can solve and tell me what x is. So gather your like terms first and shorten that problem. It's way too long now. That's right. You're going to gather the like terms. So you'd add the x's here. 4 of them plus 5 of them would be 9. Minus 2 of them. So you'd have 7 x's. And then what's left? Just loose numbers, right? Plus 2 and minus 3 would be minus 1. So your first step then was gathering all of the loose numbers. Your next step should look a bit more familiar. What is the next step in this problem here? Adding 1, excellent, because you have subtraction going on, so do the opposite. Add 1 to each side. Let's these cancel. I'm still going to have 7x on this side. 34 plus 1 is 35. So then your third and final step, this is multiplication, so to undo it, do division. These cancel, and now I have x equals 5. Did anybody get 5? Yeah? That was really tough. And this last problem is even tougher. Solve for x using both the distributive property and combining like terms. Let's decide as a group, though, where to start. Where's the best jumping off point here? I'm hearing a couple of people say, yep, parentheses, and someone said multiply the 6 through here. Yep, go ahead and do the distributive property here first. That will be your first step. So 6 times 2x would be 12x. Keep this sign here. 6 times the 1 then is 6 equals 54. Excellent, good. So the second step then is combining like terms. I don't have another loose number on this side, but I do have a couple of x's. So combine those. What is 3x plus 12x? That's right, 15x minus 6 equals 54. So we've already done 2 steps. Now we're on our 3rd step. Oh, this one's getting tough. So that was 1 step, 2, yeah. How do you get rid of this minus 6 here? You're gonna add? Addition, right. Add 6 to each side. 15x equals 60. Now your 4th step then is to get rid of that multiplication by dividing each side by 15. X equals 4. Did anybody get 4? A couple of people are saying yes? Okay, so this was pretty tough. This was a 4-step problem here. Very good.